Have you ever had a sugary treat or snack that you just couldn't stop eating because it tasted so good? Well, I certainly have with these Sour Patch Kids. Every single time that I eat one, I trigger a dopamine reward pathway in my brain. How does this happen? Let's check it out. It's all because of this little guy, a neuron. Neurons are our body's method of communication. If I touch my arm, I can feel it because the neurons relay the message to my brain. Let's take a closer look. A neuron consists mainly of dendrites that accept the message through chemical signaling, the axon that transfers the message quickly to the end of the neuron, and the axon terminal that relays the message to surrounding neurons. The myelin sheath is a protective layer of fat that coats the axon and functions in increasing the speed of the message throughout the cell. Between one neuron's dendrites and the adjacent neuron's axon terminal is the synapse. The neurotransmitters located in pockets inside the neuron are released into the synaptic cleft and will be received by receptors embedded in the dendrite of another neuron. These receptors will trigger a response by the receiving neuron. We have billions of neurons, the majority of which are located in our brain. Before we understand how neurons play a part in the dopamine reward system, we must examine the anatomy of the brain. The part of our brain that conveys feelings of pleasure and anticipation is called the limbic system. So I have a brain right here. If we cut it in half, we can see the limbic system a little bit better. It consists of the hippocampus, the hypothalamus, the thalamus, and sometimes the amygdala, as well as some of the frontal cortex. The majority of the dopamine originates from the ventral tegmental area, which is right here at the top of the brainstem. And it moves to the nucleus accumbens, which is right here at the bottom of the basal ganglia. Sometimes in the mesocortical dopamine system, it'll move to the front of the frontal lobe. There are 4 dopamine pathways in the brain, all of which begin in the ventral tegmental area, or the VTA. The major pathways are the mesolimbic and mesocortical pathways. The mesolimbic system travels to the nucleus accumbens, whereas the mesocortical system travels throughout the cerebral cortex. Stimuli that can trigger the reward system may include social interactions, food, cell phones, and substances such as opioids, nicotine, and alcohol. Being knowledgeable about the dopamine reward pathway is important because it drives human behavior and can lead to impulsive tendencies or substance abuse. Oftentimes, drugs such as opioids will not only mimic dopamine in the brain, but amplify the amount and effects of it. Research regarding the reward pathway and limbic system will allow scientists to better understand addiction and how to treat it. Imagine a world in which we can control pain and addiction. That world might not be so far away.